Random variable X has a distribution, mean 1, variance 20. Yeah? A random sample of n observations are taken. Given that 1% of the sample mean, 1% of the sample means exceed 1.55 n. Wow, quite a mouthful. So, let's again be very clear what they want. Random of n samples of X are taken. Now, X is the this is the distribution of X. Now, X bar, the X bar we're talking about is X1 plus X2 plus X3 plus X4 plus Xn divided by n. Because n samples of n are taken. So, if example, if n is 10, not this one. If n is 10, then what happens is 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you get one value, put it down. Correct? Yes? So now it's just that we don't know what is n. We don't know what is n. So, never mind, we let X bar be equals to X1 plus X2 plus X3 plus all the way Xn. Now you are given that 1% of the sample means, that means, later I explain, you copy this first. Now, 1% of the sample mean exceed 1.5. Now, this is a very interesting way of putting it. 1% of the sample mean exceed. That means we must translate it to probability. Does it make sense that if I tell you 1% of the sample mean exceed 1.5, what they're saying is the probability of the sample mean exceeding 1.5 is 0.01. I say again, 1% of the sample, on average, actually they just short of the word on average. On average, 1% of the sample may exceed 1.5. It means the probability that the sample mean exceed 1.5 is 0.01. I'm going to tell you, on average, 50% of you wear spectacles. What is the probability that I pick one student, he wears spectacles? 0.5. Correct? Make sense? So on average, 1% of sample on mean exceed 1.5, it actually means this statement below. Probability x bar is 0.5 is 0.01. This is from the question. Correct? Does it make sense? It's another way of saying probability. And repeat one more time, it's another way of saying probability. It is actually just this statement. 1% of sample may exceed 1.5. 1% is probability. So, what is the unknown here? The unknown here is n. So, how do we solve this? We still need to find this unknown number here, and then what do we want? Because the n is unknown. Now we need to find out what is the distribution of x bar. Alright, what is the distribution of x bar? Yes? Can we recall it from above? 4.5 above. If x is a normal distribution, x bar should be a normal distribution with the same mean. With the same mean. With the same mean, 1. What is the variance of x bar? It must be the variance divided by n. Correct? It must be the variance divided by n. It must be the variance of n divided by n. Can? You see, how? Cannot do already. Now we have to recall what we did in normal distribution, right? Which is why, if your friends don't know, somehow not here, absent, don't know, skip lecture because think that, not important, but this is also a good revision of normal distribution. You have known mean, unknown variance is in terms of I don't know. You want to find n. How do we solve this problem? Because if mean is known, variance is known, you want to find area, we want to find probability, or you just press calculator, we're done. But now, what to press? You just don't know what to press. How to press calculator? Nothing to press what? You inverse norm also cannot, because you don't know this thing, you don't know this one. Correct? What do? Do we have any clue? Don't know. Standardization. Use standard normal. Can you remember? Or cannot remember? Cannot? Okay, let's try. Remember not? Remember my example not? Okay, I use another piece of paper. Not paper lah. Okay. If this is x bar, if this is x, we mean 10. X, we mean 10, 2 square. If I take x minus 10, recall, I shift the diagonal x minus 10, the mean will be 0. Correct or not? I divide by 2. The standard deviation now becomes 1. So, this divided by 2 is actually my standard normal. That means it's this one. We mean 0. Do you remember this one? Yes, do you recall? So, now, what am I going to do? I am going to standardize. That means in my inequality, I take x bar minus 1 divided by, I divide by square root 20 over n. I minus 1 divided by square root 20 over n on both sides of the inequality. Oops, sorry. I repeat one more time, from here to here, all I did was to minus 1 divided by the standard deviation on both sides of the inequality. Nothing wrong, I do the exact same operation on the left and the right of the inequality. Okay, nothing wrong. Why do I do that? Because on the left hand side now, if x bar is normally distributed, x bar minus mean, the mean will be 0. Divided by standard deviation, now the standard deviation is 1. So now this is my standard normal, which is z. Got it? This is now my standard normal, which is z. Which is probability z greater than 0.5. I bring the root n up over root 20. Oh, sorry, I write my 20 properly. Equals to 0.01. Do we have a normal graph printed for you? Is it there? No. Do you have bell curve there? What? No bell curve, right? No bell curve printed there. So, where's my bell curve? Funny. Never mind. Okay, so now can we inverse norm? Be careful, okay? Okay, I don't know where's my bell curve, but never mind, it's okay. What we want to do is, you want probability z greater than something is 0.01. So that means you want this area to be 0.01, right? Because it's greater than. And this mean is 0. This mean is 0. Z, because z. Correct? So you want to find what is this value. Right? And this value now, if you can find what is this value, then this value is this. Correct? Yes? So, do we inverse norm 0.01? Be careful. Because when you enter into a GC inverse norm, the GC asks for the left bound area. For most of us at least. So, we got to convert it to a lower bound. Which means I can jump straight to probability z smaller than just take note, this is smaller than now, which means now you want this area to be 0.99. Correct? Yes? Now we can inverse norm. Now we can inverse norm from GC. And we can find what is actually that value there. Okay, very quickly, I use GC lah, just to, in case some of us really don't know how to use. Cannot be lah. Inverse this one. Okay, wait, what happened? Why so slow? This one, all right, 0.99. Standard normal mean 0, standard deviation 1, left bound, you paste. 2.32. So, from GC, this number is 2.32. Alright, so therefore, you can say this is equal to that. Some of us, quite sharp, may realize that, how come I put smaller than here and then small equal to here? Okay lah, if you don't want, then don't want this one. Actually, you should add this one in. Yeah. But it doesn't really matter. Right? Whether you have an equal sign or not, it doesn't really matter for continuous random variable. But that's for consistency, just put it there. We want to find n. We want to find n. So, you just equate this to 2.3263. Just, this is intermediate step, better leave to 5SF. Okay? I think one equation, one unknown, you just bring it across and you square both sides, blah, blah, blah. I don't think it's difficult to find n. All right? I don't think it's difficult to find n. Now our job is done. Now, do we round up or round down or round off? Don't think so much, just round off. Round off. That means if it's greater than 0.5, you just greater or equal to 0.5 and above, you round up. 4 and below, you round down. Don't think so much, just round off. N must be integer, n must be 433. Wow, my timing again damn good. Part 2, never mind. I will not carry on. Part 2, next Tuesday we'll carry on.